Welcome back. Now the production of N,N-diethyl-metatoluamide, also referred to as DEET, the primary component in mosquito repellent. This reaction is an amidization, that is creation of a new amide bond, okay, between what was a carboxyl carbon and the nitrogen from an amine. Okay. In order to do that, you need a very reactive carboxyl. So actually, we're going to first form an acyl chloride from a carboxylic acid and then react that with an amine. So our mechanism for the day, metatoluic acid and dinyl chloride. Dinyl chloride is considered inorganic and is a very strong reagent. Okay. Source of the electrons is actually the sp3 hybridized carboxyl oxygen. The target is the sulfur. Now, that sulfur already has 4 bonds. As it accepts a new bond, something has to give, and the most likely thing is the pi bond to the oxygen. As we know, pi bonds are weaker than sigma bonds. Giving us our Zwitter ion intermediate. Next step, we form the pi bond, and here again, if the bond to the oxygen we created, we're back at equilibrium, but eventually one of the chlorines gets knocked off. That chlorine then is available to attack the carboxyl carbon, kicking those electrons up. Oops, if I remember to draw the methyl in. Giving us another Zwitter ion. But those electrons are going to come back down and kick out our leaving group. The thionyl chloride, by the way, can go find another molecule of the carboxylic acid and undergo a second reaction. So you can get 2 moles of the acyl chloride for every 1 mole of the thionyl chloride. We're going to then have a secondary addition of the diethylamine. Here again, nitrogens are actually even more basic than oxygens. So we're going to take the electrons from the nitrogen, add them to the acyl carbon, and kick the electrons up. Trying to run out of room because I needed to stay within the video camera range. finally, we deprotonate to the product. Primary, secondary amines do this very well. Tertiary amines would not be available because there's no way to deprotonate it at this point. So everything then reverts back to a certain point because you just can't clean them up. Notice also that we kind of did the same thing over and over again, much like we saw with the aldol reaction. Here we have an addition and then we have an elimination. And together, they ended up giving us a substitution. Okay? Then we did the same thing again. We had an addition, followed by the elimination, and overall, from this point to this point, we substituted. Then we had, oh, here we go again, an addition and an elimination, and we ended up with the substitution. And then finally, just the deprotonation to the product. So this is the addition, elimination style substitution.